Welcome, welcome. See a couple more people coming into the room, so I'll wait just a second. For you, those of you that are here, this is going to be a hands-on session. So if you have the ability to have two screens, it'd be easier if you have two screens where you can have one on my presentation and one with the hands-on section. Or you can also toggle back and forth between two tabs when we get going. And of course, you don't have to do the hands-on stuff, but it is a hands-on session. We're going to work through a sample lesson so that you kind of get the feel for what this is like and what this looks like in the classroom. And thank you for being here at the last session of the day. I really appreciate you being here. And I hope you get something great to take away from today. And I think I'm gonna go ahead and get started. I don't see a stream coming in right now. So let's go. So this is Hey Google, why should students learn about AI and machine learning? I've already crossed paths with most, if not all of you today, but my name is Heidi Baines. I'm a coordinator here at RCOE in the Educational Technology Services unit. And you met my boss earlier, Dennis Large, and the rest of our team, Mike Leppin, Dr. Steve Hickman, Nancy and Gabby are here working on Google Camp next couple of days. All right, so I feel like, how many of you were in the keynote this morning? Because I feel like she covered a lot of what I'm about to say. It just fit so nicely with what I have here. I was like, oh, she's already covered it. I don't even need to cover it in my presentation. But if you're in the keynote, it was about media literacy and what a big role, media and social media and algorithms play in our society, and especially for our kids. And so I don't think this is a unique thing that I'm saying, that technology affects every field. You know that, right? That's why you're here. I'm kind of preaching to the choir. Everything that we do, technology has a hand in, and particularly computer science, right? This is part of a computer science strand, this presentation, and the purpose is to look at the ways that computer science affects our daily lives, but particularly our students' lives. They may not even know that they're being affected by computer science, but all of those algorithms, everything that drives their social media, the way they're advertised to. The presenter this morning talked about keeping people engage with social media longer. That's all about algorithms. And for the most part, our students don't really have a knowledge of how any of that works. We have a lot of things that are compulsory that students learn, but we're missing this piece, in my opinion, about computer science or artificial intelligence or machine learning. That is such a huge part of all of our lives, whether we want it or not, right? It's driving everything. I'm going to stop this share real quick and reshare because I realized I forgot to share with my sound. So let me reshare and include my sound. I wanted to start with just a really quick video. This is produced by ISTE, International Society for Technology Education. And this talks a little bit about AI and the need for helping our students learn about AI and machine learning.
What will a world with artificial intelligence be like? Just look around you. AI isn't the future, it's here now. While only...
What's the problem? Let's see. You guys can't hear it, can you?
It was coming in clear, Heidi, on
It's
my
coming
end.
in? I'm not hearing it at all here. Okay, I'll be quiet.
No worries.
Only 33% of people think they're using AI. Nearly 77% already are. AI recommends the right movies to watch, stops criminals from using our credit cards, and interprets what we mean to say when we talk into our smart speakers. Today's students are the first generation to grow up with AI. Artificial intelligence can already do many things that once only humans could do, like reasoning, adapting, recognizing patterns, and solving complex problems. By 2025, AI will take over more than half of all current work tasks. Employees in every industry will soon work side by side with smart machines to become more efficient and productive. And AI has the power to help us solve some of our biggest problems, like climate change, education inequality, and improving global health. But who will decide which problems AI should solve? How will we ensure our AI systems are ethical and fair? Who will decide whether AI works for us or we work for it? Our ability to answer these questions will determine the quality of our future lives. To design an AI-powered world we will actually want to live in, today's students must know how to do more than just use AI. They need to know how to harness it to create solutions that will improve lives. This won't happen on its own. Teachers are the most important link to developing the new generation of AI-savvy learners, workers, and leaders. Across the globe, students and teachers are beginning to learn about AI together. They're exploring the capabilities of existing AI tools, building their own applications, and considering what rules are needed to keep us safe. They're also learning that the more AI can perform transactional tasks, the more important our uniquely human skills like empathy, creativity, and critical thinking will become. AI is already here, and our students need to be ready. By learning to create with AI, today's students will change the world in ways we can't yet imagine. Are you ready to help students create the kind of AI-enabled world we will all want to live in? Are you ready to teach the future?
All right. So I literally could not hear that at all, but I have seen it before. What are your thoughts on that video? I know it talks about people thinking that AI is futuristic, right? Something coming in the future, but it's already here. Did anything strike you as interesting in that video? You can unmute or you can put in the chat. Anything that piques your interest? Nada? Yeah, Hannah said, this generation's growing up with AI. They don't know a world without it, right? I have a 15-year-old son. He doesn't know a world without a smartphone. He was born in 2007, right? So like, he doesn't know anything without Siri, or that's his go-to. If he has a question, he asks Siri. And that's just the way of life. Our students are first generation to learn about AI. Yeah, growing up with AI, exactly. So I feel like, none of us or most of us are not going to be AI experts, right? We have our classrooms that we teach, we have our subject matter that we teach, and to add on, by the way, become an AI expert as well, it's not a realistic ask, right? But introducing these ideas to students, and I'm going to show you a tool today that kind of teaches them a little bit about how does an Alexa or a Google Home or Siri, how do these things work? How do they learn? And how do they know the answers to our questions? Right? Like even just a little bit of exposure to how algorithms work and how these tools are driving our daily lives, I think is an important piece of information for our students to have to be, good digital citizens and to manage the internet in a way that works for them instead of, us working for the internet, right? We talked about that in the keynote this morning, is that we're making money for them, right? So how do we harness the power of the internet and harness the power of these digital tools instead of them harnessing us? So I feel like it's a really important concept for students to learn. There's another thing here. Has anyone seen Coded Bias? If you teach older students, this is about an hour long. I'm not going to play an hour video right now, but it's a wonderful documentary on bias in artificial intelligence and how machines aren't necessarily unbiased, right? Like a machine can have prejudice, a machine can have bias, and how those things can also drive algorithmic bias, and how those the way that the machines are taught and the way that machines have been coded can also exhibit bias. So it's a really, really interesting documentary. I'm going to show you just about 2 minutes, maybe less, of the preview. I'll give you access to all these slides, and they're in the SCED, and this is all linked here. So if you want to go back and look at more of this later, or see this entire documentary on your own time, this is all linked in the slides. So let's just watch another minute of this. And you can hear this because I can't, but you can hear it.
During my first semester at MIT, I got computer vision software that was supposed to track my face. It didn't work until I put on this white mask. I'm thinking, all right, what's going on here? Is it the lighting conditions? Is it the angle at which I'm looking at the camera, or is there something more? That's when I started looking into issues of bias that can creep into technology.
Our ideas about technology that we think are normal are actually ideas that come from a very small and homogeneous group of people.
Vast amounts of data at incredible speeds.
Everybody has unconscious biases, and people embed their own biases into technology.
This kid got stopped as a result of facial recognition misidentification, and then used that as justification to search you. This is an innocent child.
Racism is becoming mechanized.
Systemic issues are only going to be hardwired into new technologies.
I'm going to pause it right there. But like I said, it's really interesting look at how bias can be part of a machine, right? We think that machines don't have any bias, and this is a really, really good look at the way that these things can happen. And so like I said, if you teach older students or for yourself, it's fascinating look at machine learning and artificial intelligence and the research on that. Apologies because I can't hear it. So I don't know that I stopped it in a weird spot or not, but hopefully that was good. So like we said in the keynote this morning, we need our students to not only be ethical users of technology, we stress that a lot, right? Using it ethically, being a good citizen, but we need them to be ethical creators of technology and understand how these technologies work is that first step in raising the next generation of ethical programmers and ethical users and creators of tech. All right, so this is just a clip of what we're doing today. This is a student in San Jacinto Unified working on the project that we're going to work on right now. Cool. So what we're going to be doing is we're going to be using Scratch to teach a fan and a light, you see there on the top right, to respond to our written commands in Scratch. And we're going to be using a tool that's called Machine Learning for Kids to create blocks in Scratch that allow for machine learning and allow us to teach the machine the commands we want it to use. So it's very much, you know, how does Alexa work? How does Siri work? How do we train a machine? But on a really basic level, so that it's easy for us and easy for our students to understand, you know, how these things get started and how our machines learn. All right, so are you ready? Ready for hands-on? I want to leave enough time. Yeah. In the slideshow, before I do the rest of the presentation, there are a bunch of resources for AI. Any of these things that might be of interest to you, you can explore. There's a ton of different things. The nice thing about these resources is they're all laid out in a way to help someone teach about AI that doesn't have experience with AI. So you don't need to be an expert or have a whole bunch of computer science background to use any of these tools. They're really well laid out with a lot of really great directions and scaffolds so that educators and our students can use them in the classroom. Okay, here we go. So I'm going to be toggling between several different tabs. Mostly I'm going to stay on the slideshow, but if at any point you need me to repeat or demonstrate again anything that I've done on the screen, please don't hesitate to interrupt and let me know. I have no problem backing up and I don't mind being interrupted at all. So please feel free to chime in with the chat or your microphone if you need anything at all. So this tool that we're using is called Machine Learning for Kids. It's developed in the UK by a guy named Dale Lane. So I want to make sure I give him credit. But if you're a Twitter user, this is their Twitter handle, and you can find information there. You can ask questions there, and Dale Lane himself will chime in and help you out if you have further questions. So here's what you're going to do. First thing you're going to do is go to machinelearningforkids.co.uk. And I'm going to go out of this present mode so that I can whoops, more easily. All right, let me give you the link. running a little slow. So here's the link to all of the slides. And then here is the link to machine learning for kids. If I leave this in preview mode, can you guys see it okay? If I leave my slides up like this? Yeah, okay. All right, machine learning for kids, when you're there, give me a head nod, give me a thumbs up, let me know I can keep going. All right, perfect. So when you get there, we're not going to mess with making accounts today. And I like this feature for the classroom, because if this is going to be like a one-off lesson that you use with kids to kind of discuss this stuff, you might not want to have them make accounts either. So we're just going to click on try it now. It's not going to save, but you also don't have the hassle of accounts and passwords and things. So we're going to click try it now. And after you try it now, you're going to be at this spot. And you're going to click add a new project. It'll take you to this screen. So, and I'll pause here. Give me thumbs up when you get to this add a new project. You see John's thumbs up. And by the way, these slides, if you're teaching, upper elementary, middle, high school, these are meant for classroom use. So you can take these slides and just put the slideshow up for your kids, and it'll walk you through every step of doing this project. So these are yours. All right. So I named my project Light It Up. You can name it whatever you want to name it, but because we're working with a light, I called it Light It Up. And then you're going to choose text for this one, because the way that the computer is going to recognize our commands is through text. It can also recognize images, numbers, and sounds, but we're not working with those pieces today. We're only working with the text pieces today. Then once you have Light It Up and you choose text, I chose English to work with. There are other languages you can choose, but for today's presentation, we're going to work in English. And then you're going to click Create. And then you should find yourself here. And let me know when you are here. And it says your machine learning projects. And it has your title. And you're ready to go. I see some thumbs up. Awesome. Thank you. Thank you. And again, if I go too fast at all, please just, let me know, slow down a little bit. Okay, so once you're at Light It Up, you're going to click on the title of your presentation. So click on whatever you titled it. So in this case, click on Light It Up, and it'll take you to this screen. And when you get to the screen, you'll see the title of your presentation up at the top, and then you have some choices. You have train, you have learn and test, and you have make. And we're going to use all three of these, but we're going to start by training our computer to recognize commands. All right, everyone at train? Kind of moving at a pretty good clip here. Good, I see some thumbs. Awesome. All right, so go ahead and click on train. And you're going to get a screen that looks like this. And then if we can pause for a second, I'm going to kind of talk you through the next couple of slides, and then I'm going to back up again. So let me kind of front load you with some information, and then I'll go back step by step. So what we're doing right now is we're creating what we call labels. So we're going to create labels. Like I said, I'm going to come back to this, so you don't have to keep up right now. We're going to create labels that our computer is going to use to put like buckets of information in. Okay, so each label is going to have information in it that our computer is going to recognize. Eventually, we're going to create 4 labels, because these are the things we want the computer to learn to do. We want it to learn to turn the light on, to turn the light off, to turn the fan on, to turn the fan off. So we're creating 4 buckets of information. that the computer is going to reference back to. Okay, so let me go back to, you're all right here, right? It says recognizing text. So the first thing you're going to do is you're going to click add new label. Okay, add new label. And when you click that, it's going to ask you to label your label, right? To create a title for your label. So go ahead and call it light on and click add. And it'll look like this. And I'll pause there. Everyone doing okay? Doing all right? Tamara's doing all right? All right. Okay, so after you, Aaron's doing all right. So after you get light on, this is when you're going to create 3 more. So use that same process and create light on, light off, fan on, fan off. And I'll wait for a minute until we're all right here. All right, how are we doing? Ready? Thumbs up, thumbs down. You see another thumbs up? We're good. Good, good, good. Okay, awesome. All right, so this is probably going to be the longest part. It's not difficult, it just takes a little time. And if you're doing this in the classroom, leave some time for this because the kids are going to take a while to do this. But what we're going to do now is add examples under each label. So examples are going to be things that we might type in that the computer will recognize and then execute what we tell it to do, right? So if I am talking to Alexa and I want the light to turn on, what might I say to Alexa to make the light turn on? Or Google or Siri, or like what would I say if I'm talking to one of my AI devices? How do I get the light to turn on? Turn the light on, right? Right, so that might be an example that you put in one of these labels. So what you're going to do is you're going to click add example. You're going to get a field to fill in, right? So add an example. So add an example for light on. Just type in turn the light on and click add. Okay, or light on, or it's dark in here, or light, or right? So anything that you think you might say to get a light to turn on, put it in that box. Okay. And here's the lengthy part. It's not super lengthy, but a little lengthy. You need a minimum of 6 examples in each label to train the machine. So we have to take a little bit of time right now to add 6 examples under each label. So you can see my light on has, you know, brighter, make it bright, illuminate, turn on the light, light on, you know, light off has similar things. For fan on, I have it's hot, turn on the fan. I'm hot, make it go, right? So take just a couple of minutes and do a minimum of 6 in each of these labels. You can do more than 6, but minimum 6. And then we'll get into the next part. Okay, so take this time, probably take 3 or 4 minutes. And then as you finish this, if you can give me a thumbs up so that I know you're ready to move on, we'll go from there. And I would totally play some music, except I can't hear anything. So I don't know what I would be playing, and that sounds dangerous. So we'll have to do it in silence. How are we doing? Couple more minutes. Getting close to ready. Yep, I see a thumb. Oh, I see several thumbs. Oh, another thumb. All right. Last call for anyone who needs more time. All right, we're gonna move forward. So you're on this screen with your labels. There's one thing about this program that I find a little counterintuitive, but to get to the next page, the next step, you have to click back to project. So that's why I have this big red circle around it, because I always want to click on the right and move to the next thing, but you have to click back to project. So when you go back, you'll be back to this screen. So we're back to learn and test. Learn and test. Yeah. All right. When you get to learn and test, you're going to click learn and test. So click learn and test. And then you get to this screen. And you're going to click train new machine learning model. It'll take you here. And I'll pause here. Train new machine learning model. It'll take you to this page. And for this demo, it's only about a minute to train the machine. If you get into using images and some other things, it might take you a little longer, but this should only take you about a minute. So even as I'm talking, I bet some of your machines are already trained. Anyone's machine done? Yeah. If for some reason you're training the machine and it just doesn't ever pop up that it's done, just refresh and usually it'll come back and be like, oh, machine's done training. So like I said, for this demo, it should only take a minute or less. But here's the fun part. So after your machine is done training, you get to test it. So on the bottom, you have a nice little field here that you can type some stuff in and test. So go ahead and type in some of the things that you typed into those labels and test how much it's recognizing it, right? This is always kind of fun. Again, students love this. So build in some time because they'll type all kinds of nonsense, which is a fun discussion, right? Like, why does it recognize this and not this? And you can type in nonsense yourself, like, you know, walk the dog and see what comes up, right? But type in a few things and see if for the most part, it's recognizing the stuff that you typed in. It may not always be 100% confidence, but should be pretty close and it should be recognizing most of what you've typed. So our machine is trained and you're getting a chance to test right now, right? And while some of you are still testing, the confidence level comes in when we create the code for this, because you can trigger events in Scratch based on the amount of confidence that it recognizes in your commands. So I don't know that we'll have time to get all the way to that piece today, but I do have that in this slideshow. If you want to go further after today's session, it can say, like, if it doesn't recognize it at 80% or more, don't run this program, right? Or if it does recognize it as 80% or more, do this. So there's some if-thens and elses that can run based on the confidence that it comes back with. All right, ready? We're getting closer to Scratch. We ready? Ready? Oh, again, you got to click back to project to get back to the next screen. And then we're going to make something. So you're going to click make. I feel like I'm going fast, so please just slow me down if I'm going too fast. All right, you're going to go to make, and you get this screen. You have Scratch 3, and if you're doing this with more advanced skills, or if you're teaching a class that does like Python coding, you can do this in Python as well. You don't have to use Scratch. So there's other options here if you have some more advanced learners or more advanced skill sets that the students have. So keep that in mind. But we're going to do Scratch 3. And when you click Scratch 3, you're going to get this screen. You're going to click Open in Scratch 3. And then it'll take you to what might be a familiar screen for most of you. We've seen Scratch earlier in our computer science strand with Dr. Tomford, but this is Scratch 3. Even if you're not familiar with it, it's pretty intuitive. It's pretty easy to learn. These are blocks that program, and we can drag and drop them into this workspace to make, in this case, this cat do things. So if this is your first time with Scratch, I'm going to walk you through it. So don't worry if you've never seen it before. But here's what's great. Everyone get this far? We're all here. We're all in Scratch. Okay. If you're familiar with Scratch, you'll notice all the usual tools over here on the left. But if you look, there's an additional one that you just created. So now Machine Learning for Kids and Scratch are talking to each other, and you have an extension called Light It Up. So you should see the name of your project here built into now the Scratch platform. And if you click on your Light It Up, you'll see additional blocks. And these are the blocks that we're going to use to teach the computer to recognize our commands today. Okay, doing all right? Okay. All right, I'm going to flip to a different tab. So this is the code we're going to create. We're going to come back to this in a second. But you have your controls over here on the left. You have your extra extensions. I have an additional extension of something that I'm working on, right? But you should see all of your stuff here. We're going to work in this workspace. But what you're missing is the fan and the light, right? You don't have those things yet. So what you want to do is you want to go up here to Project Templates. And I think this is just a wonderful built-in piece of this tool, because I hate starting with a blank screen. And especially if you're a new user, or you're not, an AI or programming expert, which 99% of us are not, right? It comes with all of these templates to help you get started. So we're not going to start with a blank screen. We're going to start with a bunch of blocks already in place, and as will your students if you do this with your students. So I went to Project Templates on the top, and we're going to choose Smart Classroom Easy. And when I click that, you're going to see blocks drop into place, as well as the sprites that we need to do this project. And for me, this is a wonderful, wonderful scaffold. Creating these sprites is a whole nother, piece of Scratch. And so for this lesson, we're just focusing on how a machine learns and how, an Alexa is created. We're not getting into the part of creating the sprite, or writing the program for each sprite and for the sprite to work. You don't have to bother with that. We're only working on the machine learning part. You certainly could customize these and change these up, but I love this for the simplicity of, you have everything you need to learn this one thing about machine learning. We don't have to get into the weeds of, really deep Scratch learning, right? It's all here for you. All right, we ready? Ready? Everyone get the template laid out there? Yep, good. Okay. Here's what it's going to look like when we're done. Okay. And the way this works is when I click the green flag, it's going to ask me to enter a command. So I'm going to say fan on. And when I hit return or enter, the fan turns on. I want the fan to turn off. I write fan off, right? So this is what you're all going to create right now. Yeah. Okay. So here we go. I can't see you, so let's see. We good? Chat's good. All right, so you have this template started, right? So what you're going to do is you need to make sure you click that extension down on the left. So mine says light it up, right? And there's a little step that will make your life easier right now. See where this blue answer label is? I'm going to grab that. And if this is your first time with Scratch, you're just going to click on it. And I'm just going to drag it up and just leave it here in the workspace for a minute. Just going to get it out of the way. It's going to come back, but right now it's in my way. Okay. So I'm going to drag that out of the way. And then I'm going to go over here to my new blocks. And I'm going to take that very top block that says recognize text and label, right? Because that's what this program is doing. It's recognizing the text that we put in under the labels that we created. All right. So I'm going to grab this block. And again, I'm just grabbing and dragging. Okay. I'm going to drag it from there. And I'm going to put it right where that answer was, right in that green block, and it'll expand the green block. So right now I have when clicked, enter your command. If it recognizes the text label, it's going to turn on the fan, okay? So I need to put a block here. This is giving you a prompt of what to put here, but this is not going to do anything. This is just a helper text. So which of my labels means fan on? This one, right? The one that says fan on. So I'm going to drag fan on out of here and drag it here. Okay, doing all right? The last thing I need to do is then take this blue answer block and put it right back in over text. So now what it says is when the green flag is clicked, enter your command. If it recognizes the answer as one of those labels, right, turn the fan on. And this broadcast is talking to the sprite and telling the sprite to do its thing. All right, how are we doing? The first time I saw this, I had to see it several times. So don't feel like you can't ask to see that again. Doing all right? Do you want me to keep going? Okay, I see some thumbs. We keep going. So you're going to keep going in the exact same pattern, right? So I'm going to drag this answer out. This one is turn off the fan. So I'm going to grab my recognize my label here. I'm going to do fan off. And then I'm going to drag the answer back over. And I'm just going to do that for all four of them. So this one's turn on the lamp. So I'm going to say same top block, right? Light on. Drag that answer label back over there. And one more, turn off the light. And voila. How are we doing? It takes a minute to do it, and I've made many mistakes doing this just because I wasn't paying attention. So please don't hesitate to ask to see it again. And then once you get all of those in place, you can test it. You hit your green flag And you can start writing some commands in and see if your light and your fan turn on. And when you do, let us know, because it's really exciting. It's strangely exciting to see the light come on. Anyone got their light yet? Or their fan, either one? Oh, did I see a thumbs up? Tamara, you got it? You got it. Do you want to unmute or and celebrate?
Sure.
Yeah, there we go. Yes,
I am
John.
here.
So how did it feel, Tamara?
Fine, and I like it, just that it's really like not a lot of commands for them. So even though you had the only question I had for you is they have you do 6 for, and why do they do that for the kids? Like, because I know that if they just have multiple commands but they only needed 1 to make it work, why are they asking for 6, and what would happen if they didn't have 6?
It won't let you go forward without 6. So it literally makes you do 6. What I was told is it's just, that's the minimum of number that the training model will use. So it won't look at less than that. It wants at least 6 to look at.
Okay, thank you.
Yeah, great job. It's super fun though, you know, like, and like I said, even if it's a one-off lesson, if you're doing digital citizenship or something like that, what a great way to like pull something in and talk about, you know, how do we train computers? Who trains computers, right? How do computers learn? It's by whom, you know, whatever was input into that computer, right? Aaron says, I'm singing Lego Batman's Darkness song at the computer and the lights turn off. Did you do it with voice commands? Do you want to share, Aaron?
No, I'm not actually. I didn't get I did it just the way you demonstrated. My singing voice isn't good enough to train it to hear the actual tone.
That's fun though.
It is very fun. I can see elementary kids and middle school kids getting, and high schoolers getting way into this.
Yeah, and you know, if you start with this piece, then you can say like, well, what could you do to customize? Can you add another sprite? What other commands can you do? There's just, I think, a lot of ways to go with it. If you do want them to save their work, that does get into creating accounts, which you can do. But yeah, I think it has a ton of potential and it's a ton of fun.
Yeah, I think it's a great way to really help them. Everyone, when Siri first came out, all of us spent hours, you know, trying out all the different things that Siri would respond to, like what jokes Siri knew, and Alexa. And I think these kids have probably all spent time, you know, talking to Alexa about random nonsense, and so it's really helped them understand that all that nonsense that Alexa spits back at them, somebody typed that in as a feedback to that input. I think this is great. Yeah.
The first time I saw this, I was like, oh, like a light bulb, literally a light bulb went on for me, because I never thought about any of this. You know, Siri just works. It never occurred to me, like, how did they learn these things? And so it was a big light bulb moment for me. And I've just been excited to share it ever since I saw it for the first time. But yeah, someone or something has to be there to input, you know, the responses to these things. And John says, going back to the video also shows how you need to be intentional and be inclusive, right? Because if we're not considering all viewpoints, all people, you know, all the things that are like you said, inclusive and intentional, that we're leaving out big segments of the population, right? We want tech to work for good for everyone, not just some. Lost my train of thought. I was going to say something. I'm sure it was going to be really brilliant. Dang. It'll come back. It'll come back to me. All right. Do you want to look at one more thing? Oh, I know what I was going to say. See, I knew it'd come back. So my background is history, social science. I taught middle school and high school history before I was in ed tech. And when I look at this, I think of like doing a chat bot with like a historical figure, and how would the historical figure respond? So we've all been annoyed by a chat bot, right? Probably every day. If you call a line or you type into one of those customer service, chat now, it's never a person, it's always a chat bot. And they've learned how to respond to certain questions that they know are going to be asked on these platforms. So I imagine having some historical figure where people could come up and type in and have them answer, or a figure in literature, right? Or it just, I see a lot of potential where I could have used this in, daily instruction that would be really, really fun for kids. It's another way to show their learning, and instead of maybe, writing another essay or something, which is what I did a lot of when I taught history. So if you have any ideas as we're talking here in our last minutes together about ways to use it in the classroom, please share them, because I think there's a lot of potential there as well. On my screen, I have up a picture of one more thing you might want to add in. So this is what I was talking about earlier, where it will run the script based on confidence. So you can see here, I added in another block, and it says, recognize text by confidence. So if the confidence level is less than 80%, the computer is going to respond and say, I don't understand. Right now, if you type something in that it doesn't recognize, it's just going to sit there. It's not going to do anything. So if you want it to respond and say, I don't know what you said, this is what you can add in. So you would, again, recognize by confidence, and then you can set that parameter to, less than 50, whatever you want to set it to, and then have it say, I don't understand, which is what your general chat bots do, right? How maddening is it to type something in and it just keeps saying, I don't understand, right? We all deal with that. So that's an extension that you can do on it as well. How are we doing? Any other light bulbs? Anyone else want to share your thoughts? How you might use this in your class? Everyone get the light and fan to work? We good? I'm going to share this link to these slides one more time. And again, these slides are yours. If you are looking to use this in the classroom, and you just want to take these and copy them and put them up on the screen and use them, that's, alter them, change them, whatever you want to do. Yeah, thank you, Erin. I'm glad. I do have one shameless plug. This is way far out, but in May of 2023, so we hold something called the Computer Science Showcase here at RCOE in partnership with San Bernardino County. Everyone is invited if you're coming to us from other counties or other places. It doesn't matter what county you live in. All students and educators are invited to showcase their computer science work. And we would love to see you there. I know this is way far out and you're in the summer and you're not in student event mode, especially for May of next year. But if you're interested, here's some pictures from this year of the event. We have in-person and a virtual option. We'd love to see kids in person, but there is a virtual option if you're coming to us from a distance. Kids can submit via Flipgrid or video, and then we've created a YouTube playlist of all of their projects. But again, that's details for later. If you are interested or you want to be on the mailing list when we start sending out information about this, please fill out this form and I'll add you to it and make sure you get any information that goes out. It won't start going out till probably September. And we'd love to see you in person or virtually to share any work that your students are doing around computer science. Can be a teeny tiny 2-line of code scratch project to a big major endeavor. Anything, everything, all are welcome. We just want to see what kids are doing and the excitement on the kids' faces of the work that they do. So please keep it in mind. Again, it's open to everyone, wherever you are, all over the world. We'd love to see all the projects. All right. Any questions, comments? I know it's the end of the day. We have a few minutes left, but I can give you the gift of time if there aren't any other questions. John, your light and fans going? There's Aaron's camera. Saw Aaron's name. Here you are.
Yeah, I was just going to say, I think most of us, when we hear AI, we think about some like plasticky version of Jude Law and like a robotic person. And this is a great, well, at least my generation. I don't know if kids are still watching that now, but I think this is a great way to introduce kids to the idea that AI, the reality of AI, and that it's not necessarily attached to a robot or a robotic system, but it is very much in operation and affecting our daily lives. So it was great.
Agreed.
Yeah.
It's in our hands, right? It's everything carried around all day with us. And thank you. I've seen a lot of you in the computer science other sessions today. I'll be in all of them again tomorrow. I appreciate your interest. And even if you haven't been in the others, I appreciate you being here. It's been really fun to have a CS strand as part of Google Camp. Tomorrow at 1, I'll be presenting with my colleague, Dr. Chan, on creating an app using AppLab and code.org. So having kids solve a problem and creating an app to solve that problem. So that's what we're doing at 1 o'clock tomorrow. And then there's some other really wonderful CS presentations in the CS strand. So please join us again. We'd love to see you again tomorrow. And yeah, thanks so much.